All right, so looking at this, we're on worksheet A35, and the directions say find the discriminant, and we're using the quadratic formula. So here we go. You have several problems to do, and you have your little sheet with you, right? On the back of the sheet, we had some information, and it was to help us. So tell me what the formula for the discriminant is. B squared minus 4 AC. Okay. Now, whenever you do this for your discriminant, and this, everyone has this on their sheet because we walked around yesterday. If not, you weren't here, you need to get it. But before you can do your discriminant, you need to have it set equal to what? The ax squared plus bx plus c needs to be equal to 0. So if you look at the first two, they're both set equal to 0. I'm good with that. Got it? Now, so you can jump in, and what you would do is you would pull your A, your B, and your C, just like we talked about. And once you do that, I'm recommending you template it, and then you fill in your B squared minus 4AC. Okay, so when I go to number 3 or number 4, neither of these are set equal to 0. So real quick, looking at number 3, when I go to get this set equal to 0, I want to get rid of the 4. What should I do? Subtract it. Now, what would I pair it with? Are there any like terms over here? -1. I would pair it with the -1. So I would end up with what? 3k squared. Then what would I want next if I have k squared? I'd want the 4k, positive 4k, and then my constant, which would be what?
What's that?
Well, that's me messing up. And then -1 minus 4, I put it together as a -5 equals 0. All right, so now you're still going to finish that. The next problem that we're fully focused on and not giggling and laughing and talking. So you're going to finish this one. I'm jumping over to number 4 with you. I want to set this equal to 0. When I go to do this, what do I want to move over? I want to add the 9v over. Now, are there any like terms with this 9v? See that they're not. So one of the problems that we were having is people not putting this in order. So the first thing I want is my v squared, -7v squared. The next thing I want is my v, so positive 9v, and then my constant, which is going to stay as -9 equals 0. Okay, so one of the things I was seeing the other day, and I'm just going to do this off to the side. One of the things that I saw the other day were people doing, not putting in order. They were going -7v squared minus 9 plus 9v. Now that's okay, but what happens if you're not paying attention? When I compare these, what should the a value be? A is paired with v squared, so it should be, and that's not an issue. What should the b value be? Positive 9, because it's paired with v. But a lot of people were looking at this and saying it's -9. So you need to pay attention. Here's my v squared. Here's my v. They're both positive 9. And then c is my constant, which is -9. That's why we put it in standard form, so we don't mix up the values for a, b, and c. Okay, now template your discriminant. It's b squared minus 4 times a times c. So even if I think I have it memorized, I'm just sort of double checking that I had it right. And let's plug it in. B is positive 9 minus 4 times a is -7 times c is -9. All right, now next thing. I say we just type this whole thing in our calculator using our parentheses. So 9 close parentheses. I'm going to suggest a lot of you are using your caret and then the power 2. You have a little x squared. It's going to save you a key.
Exactly.
All right, -4, and you can either do times or parentheses, -7, -9. Let me also remind you of this. When you're looking in your calculator, the minus sign is a little bit longer and it's down lower, and the negative sign is a little bit shorter and it's up higher. Do you see the difference in the signs? Because that would change things. All right, I get -171. Does anybody agree with me?
Yep.
All right, this is all the top asks for. Do you see that the top only asks you to find the discriminant? So in the top, I am done. Are we all clear on that?
Yeah.
That's it. Find the discriminant. Okay, now move on to the bottom. It says to use the discriminant to determine the number of real solutions in each equation. Okay. If I'm going to use the discriminant, guess what I need to find?
The discriminant.
I need to find the discriminant.
Oh, really?
Okay. So let me flip it over. They're all pretty much the same. So let's just do number 5 together. What am I going to do? Set it equal to 0 by adding 10.
Okay, really?
Yep, it's exciting. Negative x squared plus 2x minus 1 equals 0. Take a second, pull your A, B, and C. We're not doing anything different here. A is what?
1.
All right, A is negative 1. B, 2. C, negative 1. Get your discriminant formula templated. The B value is 2. We're going to square it. Minus 4 times A is negative 1 times C is negative 1. All right, I'm suggesting we type this in the calculator. All right, you're telling me it's 0? Okay, and I agree with you because that's going to be 4 minus, and that's going to be a positive 4. So we do get our 0. Now, that's my discriminant. But the question said, how many real solutions are there?
2.
Well, let's think about where does the discriminant belong? The discriminant belongs in the quadratic formula under the square root sign, right? So what is the square root of 0? 0. So that's a rational number. We agree? So rational and real. And when I say I have a number plus 0 and a number minus 0, does that change anything? That's where I'm going to get that one solution. Okay? I only get one solution. It is one real solution. And we took this a little bit further. What did we say? Not only is it real, but it is rational. Why is it rational? Square root of 0 is 0. 0 is a perfect square, so we get that nice answer. Okay, so there are a different set of problems on the back. This is the last thing I want to go over. I highly recommend you pay attention. The back says to solve using what? The quadratic formula. Okay, now, do you notice that number 9 is already set equal to 0, so that's nice. What do you need to do with number 10 to start? Subtract 9. I will tell you that 9 and 10 end up with perfect squares under the square root sign, so then you can finish those, okay? But 11 and 12 are a little bit more. So let's talk about number 11 here. First things first, I need to set it equal to 0. What should I move? I'm going to add 12a. Now pay attention to where you put it. I'm going to have my add 12a just stuck down here in the middle because there are no like terms. So what should I write first? The 4a squared. Now what do I want next? The 12a or the 20? The positive 12a, and then what? The minus 20. So the order will make a difference for you. I'm still doing the same thing. I'm going to pull my A, my B, and my C. So what is A? Positive 4. What's B? And C? Make sure you get your negative sign. Okay, now we're not just finding the discriminant. We're doing the whole thing, right? So using your sheet, I have my quadratic set equal to 0. I pulled my A, B, and C. Here's my quadratic formula. So we're going back for a couple days. This is where we put in our template. So we're doing everything here. So take a minute, use your orange sheet, write out your template, using parentheses to replace all of the variables. All right, once you have your template out using this sheet, now we're going to fill in using our formula. So the first is negative b, which would be negative 12, plus or minus, and then I take my square root, and I put the b in here, and I square it, minus 4 times a, which is 4, times c, which is negative 20. All over 2 times a, which is 4. Okay, at this point, do you remember that we look at the 3 pieces? So we're not trying to do all this at once. We are going to clean up that negative 12. What's underneath the square root in our denominator? So you're not typing this all in the calculator at this point. So I have negative 12 plus or minus something all over 8. Anyone have that something for me? It should be 464. Now, I'd like you guys to take a minute and make sure we agree. Okay. So here's the deal. On number 9 and 10, once you get to this point, you'll be able to take the square root and get a nice number, and then you'll add it, get an answer and divide, and you'll subtract it. The problem is 464, if I test it, it's not a perfect square. So I can't take the square root of that. Now this one's a little bit of a bigger number, so how do we break it down? 464, I'm going to come off to the side, and you know, it's a pretty big number, so I just sort of started with 4, and I found out that 4 went into it. And if I wrote it down, that'd be the square root of 4, and I think it was 116. 464 divided by 4. Okay, that's not the biggest perfect square because I knew 4 went into 116 29 times. So basically, I found a perfect square, and then I kept working. So I'm helping you guys out. That's a bigger number. This should be the square root of 16 times the square root of 29. Now, I do expect you can break roots down, but that one was a pretty big one. That's why I wanted to help you out with it, okay? Because you'd be here for a while. The square root of 16 is what? 4. Keep the square root of 29. So we found the biggest perfect square, 29's prime. We broke it down. So here we go back to the problem. I have my negative 12 plus or minus 4 square root of 29, all divided by 8. Now, at this point, that's pretty much as far as we have gone. A lot of our perfect squares came out nicely, and we didn't have to deal with this. That's as far as we've gone, but now we're going to take it one step further, and that's why I want to do this with you today, because number 12 does the same thing. Do you see the 3 pieces you have in this problem? You have this negative 12, you have this 4 times the square root of 29, and this 8. Now that square root of 29 is attached to the 4, so we can't touch it. But do you see the 12, the 4, and the 8 all have a common factor? What do 12, 4, and 8 divide by? They all divide by 2. Go higher than 2. Yeah, when you look for the greatest common factor, it's sort of like an oxymoron. 4 is the biggest number that divides into everything, right? So I'm always going to try that number. And 4 does divide into here how many times? 3. And 4 divides into here once. And how many times would 4 divide into here? Twice. Now, the only time I can reduce if I can take it out of all 3 pieces, and this just comes along for the ride. So my final answer, which is a little step up from what we were doing, is now negative 3 plus or minus 1 square root of 29 all over 2. I don't need the 1 there because I have my square root of 29 whole spot. Do you notice that my fraction bar goes underneath the whole thing? Okay. Now, you're going to have the same outcome in number 12, and I'm going to give you a hint. Whatever number you get underneath the square root, it divides by 9. 9's your perfect square. So I'll put a little 9 here. 9 is your perfect square. So you know how to break 464 down? I use 16 and 29. Well, whatever you get, 9 is going to be the number that divides into it. Okay? All right. So once you get this done, bring it up to us so we can check it.